Hello to my fellow friends, I'm Jabatan today. In this video, my group members Karen, Melby, and I are going to talk about and introduce our research, the incorporation of marine seals into eco-friendly brick production. This research is studied to reduce the shortage of river sand in Malaysia. In this research, 3 types of marine seals, which are oyster, cockle, and mollusks, are crushed into powder to add as 10%, 20%, and 30% fine agate replacement. Furthermore, several tests such as water absorption tests, compression strength tests, dry density tests, and some tests are carried out in the laboratory to determine the brick properties. Moreover, test result is compared with the control cement brick to establish the workability of the marine shell used in the brick production. The first objective of this research is to compare the dry density of the marine shell brick with regular cement brick. Secondly, is to compare the compression strength of the marine shell brick with regular cement brick. Thirdly, is to compare the water absorption ability of the marine shell brick with regular cement brick. And lastly, is to determine the workability of the marine shell as material in fire brick production and the impact of production to the community. Next, Karen will continue to talk about the scope of the research.
Hello, I'm Karen Grade Suling. The focus of this study is to design eco-friendly brick made by the marine shell waste. The cement brick with the composition ratio for cement to sand as 1:3 with 0.5 water cement ratio is prepared with the fine aggregate partially replaced by the crushed marine shell. A total of 24 cement cube specimens with the standard size, which is 150 mm to the height, width, and the length of the cube, were prepared to conduct the test, with 6 cube specimens of each series of the cement block at the age of 7 days and 28 days. The cube specimen will be cured by submerging in the water tank at 27 degrees Celsius for 7 and 28 days. The design brick size will be 260 mm size with 103 mm size with 65 mm. British standards is used as reference for preparing the cube samples. The workability, dry density, water absorption ability, and the composition of the bricks are determined at the age of 7 days and 28 days. The optimal content of crushed marine shells is determined after analyzing the data from the plot graph obtained. From the data that obtained from this study, the cement brick with 30% of replacement CMS30CB has the highest slump value, which is 75 mm, which shows that medium degree of workability. The control cement brick CB has the lowest slump value, which is 55 mm, that shows a medium degree of workability. The workability of bricks mixture increase when the percentage of crushed marine shell increase. The different type of crushed marine shell, such as cockle, mollusk, and oyster, act as catalysts in this cement brick mixture. There is only a slight change in the dry density of the crushed marine shell cement brick of all series after 7 days and 28 days of curing. The trend of the graph is considering constant. It is conclude the percentage of crushed marine shell added does not affect the dry density of the brick. So next, Melby will continue to talk about the water absorption test.
The cement brick with 30% replacement has the lowest water absorption, which is 1.49% on the 7 days and 1.59% on the 28 days. The control cement brick has the highest water absorption, which is 1.79% on the 7 days and 2.15% on the 28 days. From the graph, the water absorption of the crushed marine shell cement brick decreased over the curing period, and it decreased when the percentage of crushed marine shells decreased. This is because the crushed marine shell acts as a barrier to water penetration. The cement brick with 30% replacement has the highest compressive strength, which is 18.34 MPa on the 28 days. A different result was obtained when compared to the researcher. From the graph, the compressive strength of the bricks increases over the curing period and also increases when the percentage of crushed marine shells increase. This is due to the crushed oyster and mollusk shell act as a coarse aggregate in brick. Therefore, the strength of the brick is increased when the percentage of crushed marine shell increase. 30% crushed marine shell perform better in all testings. Findings suggest that another locally made environmentally friendly marine shell brick is possible and suitable to be produced for use in the construction industry. Therefore, the pollution issue related to the disposal of marine shell as a dumping site will be reduced as a lesser number of shells would end up as waste. This could also reduce the shortage of sand in Malaysia. The use of marine shells in brick production has a good effect, and further innovative research can solidify its utilization in the drive towards sustainable development. More research could be carried out on the use of different types of marine shell, such as clam shell, scallop shell, mussel shell, in the production of eco-friendly bricks in the future. In future research, microstructure of marine shell added into cement bricks mixture to act as a fine aggregate could be studied, as microstructure could strongly influence physical properties of cement bricks, such as compressive strength and water absorption ability. So that's all from us. Thank you for watching this video.